Hello everyone, welcome to our video on how do we multiply and divide integers. All right, if you want to pause to give the do now a chance, now would be the time to do so. I'm going to go over it. So this question is asking you to fill in the table to the right here. And it says, if necessary, use the pattern formed by the first three products to assist you with the last three. That's going to be really important here. So I'm going to start filling in our table. 4 times 3 is 12. 4 times 2 is 8. 4 times 1 is 4. If we remember our 0 property, 4 times 0 is 0. And this is our first time encountering multiplying with negative integers. So if you want to recognize the pattern that's going on here, you may notice that we are decreasing by 4 each time. So if we continue that pattern, if I subtract 4 from 0, I'm going to be 4 into the negatives. If I subtract or decrease 4 from there, I'm going to be 4 more into the negatives. 4 more into the negatives are thinking of it getting 4 degrees colder if it's negative 4 degrees. Now it's negative 8 degrees. 4 less than negative 4 is negative 8. So what pattern do you notice when you read down the product column? Well, you are subtracting 4 from the previous number. What do you notice about the product of a positive and negative integer? Well, what I'm noticing is that when I multiply a positive number like 4, or a positive integer, with a negative integer like negative 1, I'm getting a negative product. Same thing when I did a positive 4 times a negative 2, I got a negative 8. The answer is negative. And this concept is going to be really important as we move forward in this lesson. So time to investigate. Using your answer to C above, fill in the table. So we're going to recognize the fact that when we multiply a positive integer with a negative integer, we're going to get a negative integer. Negative 4 times 4, that's a 16, but a negative times a positive is always going to be a negative. Negative 4 times positive 3. 4 times 3 is 12, but a negative times a positive is a negative. And as you notice, each of these is going to be a negative times a positive. There's going to be one little curveball thrown at you here with the zero property, but negative 4 times 2 is negative 8. Negative 4 times 1 is negative 4. Negative 4 times 0, even if it's a negative number being multiplied by 0, the product is still 0. Now, as we move on, I'm noticing these last two is a negative times a negative. If I stick to the logic we used above and we follow the pattern, what's happening here is we're actually adding 4 each time. Adding 4. Adding 4, adding 4. Negative 4 plus 4 is 0. Keeping that pattern going, 0 plus 4 is 4. 4 plus 4 is 8. You may notice here a little bit of a different strategy when we multiply two negative integers with each other. Let's write down our pattern here. You add 4 to the previous number. That's the pattern that's going on here. And what do we notice about the product of two negative numbers? The answer is positive. So what we can conclude from these two examples here is when we multiply a positive times a negative, we get a negative. But when we multiply two negatives, we get a positive. So that brings us to our notes for today. We're going to write down the two different instances of multiplying and even dividing integers with positives and negatives. So when we have same signs, the answer is always going to be positive. For example, 9 times 3, 27, we know that. But also, a negative 9 times a negative 3 is also going to be 27. As I like to say, a negative times a negative is a positive. Think about that strategy we were using when we were noticing that two negatives were next to each other. They became a positive. Same thing here. Two minus signs. If we throw them together, they magically transform to become a positive. Negative times a negative is a positive. And this works even when we divide. 9 divided by 3 is 3, and a negative 9 divided by a negative 3 is still going to be 3. So if you have two negatives, you almost just ignore the negatives, do your multiplication or division as usual, and make sure your answer is positive, because multiplying two positive numbers gets a positive, multiplying two negative numbers gets a positive, dividing two positive numbers gets a positive, dividing two negative numbers gets a positive. Now we have different signs. When we multiply or divide with different signs, the answer is, I'm sure you know, negative. For example, 9 times a negative 3. Notice I use parentheses to show the operation of multiplication. That's a negative 27. Or negative 9 times 3 written like this is still negative 27. 9 divided by negative 3. 9 divided by 3 is 3, but we had a positive divided by a negative, so our answer has to be negative. Or if we write it like this, negative 9 divided by 3, that also is going to be a negative 3. So to conclude, when we have different signs, the answer is going to be negative. A positive integer multiplied by a negative integer is going to be a negative answer. And a positive integer divided by a negative integer is going to be a negative. Or a negative integer divided by a positive integer is also going to be a negative. Watch those signs. So let's try some examples together. 8 times negative 6. That's a positive times a negative, so I know my answer is going to be a negative. And 8 times 6 is 48. Number 2. I have two negatives being multiplied together, so I know my answer is going to be a positive. So all I need to do is 22 times 5. 5 times 2 is 10. 5 times 2 is 10, carry the 1. We get 110. It's going to be a positive number. Negative 17 times 0. Anything times 0, positive or negative, is going to be 0. Number 4. We have 3 integers here that we're multiplying. Let's use PEMDAS. We're going to multiply from left to right. So I'm going to do negative 3 times 2 first. A negative times a positive is a negative. 3 times 2 is 6. Times 5. So negative 6 times 5. Once again, negative times a positive is a negative. 6 times 5 is 30. My answer here is negative 30. Number 5. Negative divided by a negative. We know a negative divided by a negative is a positive. 36 divided by 6 is 6. So just because there were two negatives here, that negative does not come with when we divide. Negative divided by a negative is a positive. 72 divided by 3, a positive divided by a negative. We know our answer is going to be negative. So now I just need to figure out what 72 divided by 3 is. 3 goes into 7 twice. 3 goes into 12 4 times. We get a negative 24. Number 7, word problem. A beluga whale is diving downward at a speed of 2 meters per second. What integer represents the whale's change in position after 45 seconds? So, this whale is diving downward at 2 meters per second. So for every second, the whale is diving downward. So this is going to be a multiplication question. The question is, what two integers are we multiplying? Well, if the whale is diving downward at a speed of 2 meters per second, diving downward is a negative value. So we're going to multiply negative 2 times the amount of time that whale is diving for 45 seconds, because they are going down, diving down 2 meters for every second, and there's 45 seconds. And negative 2 times 45, well, we have a negative multiplied by a positive, so we know the answer is going to be a negative, and 2 times 45 is 90. So our answer here, what integer represents the whale's change in position after 45 seconds? Negative 90, which tells us that the whale is 90 meters under water. Number 8, Mrs. Johnson kept track of a stock she was considering buying. She recorded the price change each day. What was the average change per day? A little bit of a challenging question here. If you're unfamiliar with what stocks are a certain product has a value if you have a stake in that product, and stocks change over time. So for example, some days a stock may have a high price, some days it may have a lower price. It changes with how people are buying and selling the stock. And what we have here is an example where Mrs. Johnson has this stock, and you can see the price of the stock changing throughout the week. So we want to figure out what the average change is for each day. And if you recall, we did mention it earlier on in the year, but the way that we figure out what an average is if we take the sum of all of the values and divide by how many there are. So we first have to add all of the different stock prices throughout the week. So we're going to add -1, +3, +2, plus a -5, +6. So let's use our PEMDAS to figure out what this is. I'm going to go from left to right. -1 plus 3. -1 plus 3, our signs are different, so we take a difference. 3 minus 1 is 2, and we keep the sign of the higher absolute value, which was the 3. This is flashback all the way back to the adding integers lesson. Rewrite everything else. 2 plus 2 is 4. Rewrite everything else. 4 plus -5. Different signs, we're going to find the difference. 5 minus 4 is 1, and we're going to keep the sign of the higher absolute value, which is going to be the -5. So this is a -1. Bring down everything else, +6. Last one, -1 plus 6. Different sign, difference. 6 minus 1 is 5, and we're going to keep the sign of the highest absolute value, which is the +6, so the 5 stays positive. Now we're not done, because we just found the sum of all of the values of the stocks throughout the week. I had mentioned that the average change per day is if we divide this value by how many days there are. Well, how many days are there? 1, 2, 3, 4, 5 in the week. Not in the whole week, but during the work week, if you will. And just a little bit of a piece of information here. The stock market is only open during the weekdays, so it is only open 5 days a week. So this $5, we are going to divide by those 5 days of the week that the stock market is open. 5 divided by 5, which we know is 1. We didn't really have to use our facts that we learned earlier, because we know when we divide two positive numbers, we get a positive. But that is something that we learned in this lesson, that a positive divided by a positive stays positive. So to answer the question fully here, on average, the average change is $1 per day. Great. Now it's time for you to try. If you want to give these questions a try, now would be the time to do so. I'm going to go over the answers right now. 150 times a negative 3. Positive times a negative is going to be a negative. And 100 times 3, may use some mental math here, is 450. So our answer is a negative 450. Number 10. Negative times a negative, we know it's going to be a positive. And 11 times 9 is 99. That's a positive answer. Number 11. I don't know where I got 2 from. Negative 2 times negative 5 times 4. We're going to use PEMDAS. Negative 2 times negative 5 is 10. Times 4, we know that is 40. The key thing here was recognizing that a negative times a negative is a positive. Number 12, 80 divided by negative 20. Positive divided by a negative is going to be a negative. 80 divided by negative 20 is negative 4. Awesome. Number 13, 0 divided by negative 23. Not so sure we discussed this property, but I'm going to explain it to you now. If we divide 0 by anything, positive or negative integer, we are going to get 0. Number 14, negative 125 divided by negative 5. Negative divided by a negative is a positive. We just need to figure out what 125 divided by 5 is. 5 goes into 12 twice. 5 times 2 is 10. 5 goes into 25 5 times. Our answer here is a positive 25. Number 15. The record low temperature in Louisiana is negative 16 degrees Fahrenheit. The record low temperature in Maine is 3 times lower than Louisiana's record low temperature. What's the record low temperature in Maine? 3 times lower. So we need to multiply that negative 16 times 3. We know a negative times a positive is going to be a negative. Now it just matters what 16 times 3 is, which is 48. Sorry, my 5 just transformed into an 8. So the answer here is a negative 48 degrees, or even 48 degrees Fahrenheit below 0. Either of these work. Last question, number 16. Mr. Reed kept track of his blood sugar daily. He recorded the change every day. What was the average change per day? Here we go. We're going to find an average again. So we need to find the sum of all of his blood sugar levels. We're going to divide by the total amount of recordings. So we're going to do negative 8 plus 2 plus 4 plus a negative 9 plus 6. Let's do our order of operations. Negative 8 plus 2. Different signs, difference. 8 minus 2 is 6. And this is going to be a negative 6 because the absolute value of negative 8 is bigger than 2. Bring everything else down. Negative 6 plus 4. Different signs, difference. 6 minus 4 is 2. We're keeping a negative because the absolute value of the negative value here is bigger than 4. 6 is bigger than 4, so we're keeping that negative sign. Bring everything else down. Plus negative 9 plus 6. Negative 2 plus negative 9, same sign, sum. 2 plus 9 is 11, and we keep the sign. Negative 11. Plus 6. Different sign, difference. 11 minus 6 is 5. Now we just have to figure out which sign we're keeping. And the absolute value of negative 11 is bigger than the absolute value of 6, so the negative symbol carries through. So that's the total amount of all of the unit changes of the blood sugar. Now we need to divide this value, because we're trying to find the average here, by the total number of recordings, which we know is 5. And negative 5 divided by 5, well, a negative divided by a positive is a negative. And 5 divided by 5 is 1. So we have a 1 unit decrease per day. We change -1 on average per day. And that's it. Multiplying and dividing integers with a negative twist. I hope it made sense to you. To summarize, why do multiplication and division have the same rules? Well, the reason why they have the same rules is because they are inverse operations. So that's it. Hopefully you understood and you can remember that a positive times a positive is a positive, and a negative times a negative is a positive. Positive times a negative is a negative, and the same thing works for division. And that's it. Hope you have a great day, and we will see you soon.